Okay, so for this one it says use the graph to fill in the graphical characteristics. So let's take a look at the first one. The first graph here, I know that looks like there's a vertical a vertical asymptote, and that vertical asymptote is at x equals 0. All right, and if you remember our trick for vertical asymptotes and horizontal asymptotes and whether they go with exponential or logarithmic, we have EH, okay, so that's exponential with horizontal, and LV, which is logarithmic with vertical. So for this particular one, because we have a vertical asymptote, my vertical asymptote means that my function family is logarithmic. All right, so our parent function is f of x equals log of x. Asymptotes, we already said were x equals 0, okay, because that's my vertical asymptote there. So then the domain, there's nothing here on the left side, so we have 0 to infinity, and the range down to up is negative infinity to positive infinity. Zeros is where it crosses the x-axis, so I have a 0 there at 1, 0, but when it asks for the zeros, we write it as x equals 0. My x-intercept is 1, 0. It never crosses the y-axis, so we have no y-intercepts. Increasing or decreasing, remember if you're riding a roller coaster, I'm going up, 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 so it's always increasing. And the increasing is going to match my domain, so 0 to positive infinity. Okay, local max or min, there's none, because remember max or min are change in direction. And then finally, in behavior as x approaches infinity, so as x is approaching infinity, what's happening here at the end of the graph? It's approaching infinity as well. Next, family of functions. So let's take a look at this graph. I notice for this graph, okay, I have a horizontal asymptote at y equals -1. And we said horizontal goes with our exponential. So we know that this is exponential. So for exponential, our parent function is f of x equals (10 to the power of x). All right, so for our asymptote here, our asymptote we said was at y equals -1. For our domain is going to be negative infinity to positive infinity. Remember, that's left to right. Range, my first value of range is -1, and that goes to positive infinity, down to up. 0, so where it crosses the x-axis, so it crosses right here at 0, 0. So x equals 0. My x-intercept is at 0, 0. Whoops. My y-intercept at 0, 0. Then if I'm riding a roller coaster, I'm going to go down the whole time, so there's no increasing. And decreasing is going to match my domain, so negative infinity to positive infinity. Max or min, none. As x approaches infinity, f of x, so what's happening way out here? F of x is getting closer and closer to -1, and it never crosses that. If x approaches negative infinity, f of x approaches positive infinity. All right, and then the last part of the test is going to be review. So you need to make sure you're able to answer some of these review questions. These are similar to what you're going to see on the test. So the expression is equivalent to the 4th root of 16 x to the 15th y to the 17th, where x is greater than 0 and y is greater than 0. So let's look at all these separately here. So I have the 4th root of 16, the 4th root of x to the 15th, the 4th root of y to the 17th. All right, let's just check to see if this 4th root is a perfect 4th. So you're going to go to math, and then you're going to go down here to number 5, and notice that it's a and s, but I want to know the 4th root. So I'm going to do 4 here, and I want to know what the 4th root of 16 is. That's going to give me 2, so it is perfect. Remember the other way that you could check that would be go into y equals. Go into y equals and do 16 divided by x to the power of 4. Go into your table, and in here, notice here that I have 2, 1. That means 2's on the outside and 1's on the inside, but the square root of 1 is 1, so that we lose the square root symbol. So I now have 2 on the outside, and then I have the 4th root of x to the 15th. So how many groups of 4 can I take out of here? Now you could list 15 x's if you want to. 1, 2, 3, 4. 1, 2, 3, 4. That's 8. 1, 2, 3. That's 12. 1, 2, 3. Okay. But notice that instead of asking us like what is simplified, okay, it's actually, if we look at the answers here, it's asking for this in rational exponent form. So it's actually not asking us to see how many groups that I can take out, which is normally our procedure. What it's asking me is which is equivalent. So I'm actually, if I proceeded to simplify this, let's just go with this for just a second. I've had x to the 3, and then I have 3 left, so x to the 3, and this is the 4th root. And y to the 17th, how many groups of 4 y's can I take out? Well, I could take out 4 groups of 4 y's, which leave me 1 y on the inside. But notice that's not what happened here, okay? So on this particular problem, you kind of really need to look to see how the answers are presented. This one's rational exponent form. So let's take a look here. We said that we had the 4th root of 16 gives me 2, okay? And then I still have on the inside x to the 15th, y to the 17th. Well, I know the 2 came out, so I could write this. Remember that this is the denominator. This is the exponent. So the index is the denominator. The exponent is the numerator of my rational exponent. So I've got x to the power of 15 over 4, and then y to the power of 17 over 4. So this is what they're looking for here. So 2, 15 over 4, 17. So this one, oh, no, I need 2 on the outside, so that one doesn't work. This one right here is the one that works. Okay. And then if you kind of look through the answers, if you weren't sure how to do that one, you could look to say, well, I know that this isn't work. This is not the same as this. This one's not the same. Neither is this one. So this one has to be the same. All right, let's look at the next one. Which of the following functions does not have a range of only real numbers greater than or equal to 0? So y is greater than or equal to 0. So I want not greater than, or I want not greater than or equal to 0. So I've given several functions here. I'm actually going to go ahead and look. Let's graph this. So I have the square root of 4 minus x. Look at that. So range, it starts at 0, goes to positive infinity. But I want not greater than y equals 0. So that one works. Go back to y equals. Remember absolute value, math. Okay, and over to num is the absolute value. And this one's x minus 4. All right, let's take a look at that. Range is 0 to infinity, so that one works as well. And remember, we're looking for not. So I'm looking for something that's not y is greater than 0. All right, let's go back into our y equals. This time I have x to the 4th. Take a look at that. Again, I have 0 to infinity, so that one seems to work. So it's got to be the last one. Let's do log x. Close my parentheses. Notice that this is going from negative infinity to positive infinity. So which one is not y is greater than 0 is going to be D. Okay, next one. What is the solution of the following equation? Okay, so for this particular one, if you remember from last unit, I need to make all my denominators the same so I can solve the top. So in order to make, it looks like the least common denominator is x. In order to make this term x. I need to multiply times x on the top and the bottom. Notice that everything now is x, so I can just solve the top. 1 minus x plus 2x equals 7. Combine like terms, 1 plus x equals 7, minus 1, x equals 6. So my answer is 6 there. Remember, the trick there is to get that least common denominator. Last one, assuming no denominators equal 0, completely simplify. Remember that this line right here means divided by, so the first thing I'm going to do is I'm going to make it look pretty. Divided by m minus 5, over 7m to the 6th. But remember, we can't multiply, so we're going to stay, change, flip. So stay, change to multiplication, and flip. All right, so now we can cross out. Notice m minus 5 and 5 minus m. They kind of look similar, but they're different. Now, I want to switch this one up so that I can see what it looks like with the variable in front. So let's just take a look at this. Okay, I'm going to write this as negative m plus 5. All I just was switch the order. It's negative m, and then this 5 is positive, so I just switched the order. But my problem is I want it to match with this, but I noticed that that leading term is negative. And when we talk about factoring, often we say if that leading term is negative, to go ahead and factor it out. So negative 1, negative 1. So that's going to give me negative on the outside, m minus 5. Okay, negative. Well, look, now it matches. So I'm going to write negative m minus 5 on the top over 42m squared times 7m to the 6th over m minus 5. Now you can start crossing out. So I have the m minus 5, m minus 5. Notice I still have the negative. Okay. The 7 and 42, I know 7 goes into 7 once. So I have a 1. 7 goes into 42 6 times. That's 6. M to the 6 over m squared. M squared will go away, which leaves 1. And then m to the 6, so 6 minus 2, which is going to leave me m to the 4th. So I have my m to the 4th here. Now we can multiply straight across. Negative 1 times m to the 4th is going to give me negative m to the 4th over 6 times 1, which is 6. That's your final answer.